That word naive, that isn't just some stylistic choice, right? It refers to the foundational, defining, and arguably um, problematic characteristic of this algorithm.
Yes, the naive part is absolutely central. It refers directly to the strong independence assumption that the algorithm makes. What naive Bayes assumes is that, given the class, each of the attributes or features are conditionally independent of each other. So in simple terms, if you know an object is, say, a dog, the algorithm assumes that the probability of it having long legs is completely independent of the probability of it having brown fur, given that it's a dog.
Which, in the real world, is often not true. Features are frequently correlated. Long legs might be more common in certain breeds, which also tend to have brown fur, for example.
Precisely. But calculating the true joint probability text features without making that independence assumption would be computationally, well, a nightmare, especially if you have many features. It would become intractable very quickly. You'd need an absolutely enormous amount of training data to reliably estimate the probability for every possible combination of feature values. So the naive assumption is essentially the computational shortcut. It allows that complex joint probability calculation to simplify dramatically. It just becomes a product of the individual conditional probabilities. PC MathBFX becomes proportional to multiplied by the product of PC for every feature dollar. And multiplying probabilities is way, way easier than calculating that massive joint probability. This simplification is what makes naive Bayes so incredibly efficient.
Okay, but as you said, features in the real world, things like height and weight, or maybe certain behavioral attributes are almost always correlated to some degree. That means the independence assumption is very often violated in practice.
That's the critical point of friction, absolutely. In reality, that core assumption often breaks down, sometimes quite severely.
So, despite this known flaw, let's walk through the implementation. In the training phase, how does the algorithm actually learn the pieces it needs?